In this video, I'll be showing you how to solve exponential equation by taking logarithm of both sides and using the calculator to round your answer. Okay, so here is the first example. I gave you 2 to the power of x equals 100. So because we don't have a particular integer value, like for example 2 to the power of 6, we know 2 to the power of 6 is 64. And we also know that 2 to the power of 7 is 128. Okay, these are integer values, but we don't have 2 to the power of something equals 100. We don't have that. So this x will be an irrational number. When we finish looking for it, it's not going to be a rational number because it doesn't fall into one of those categories that you have a particular number for. All right, so just to let you know, that's the kind of equation we're going to be finding when we solve this problem. Okay. All right, so we're going to get started. What we will do is we're going to take a natural log of both sides. Basically, we're going to just apply ln, natural log of both sides, like this, and like natural log of 100 on the right side, and natural log of 2 to the power of x on the left side. The good thing about this, why it is very neat, is because we can apply the property of exponent that we learned before. Okay, when you have a power, we can actually bring this exponent down to the front like this. So we can write it like x times ln of 2 equals ln of 100. And so then now to get x by itself, what we do is divide both sides by ln of 2 and ln of 100. And so we can just cancel out this ln on the left side and leaves us with x equals ln of 100 divided by ln of 2. Sorry about that. This is 2 over here, ln of 2. Okay, so this is the exact solution right here. This one is the exact solution. If you are looking for approximate value, we just need to turn on our calculator, like I'm going to turn it on over here. Let me bring it closer. And then we can actually punch ln. So this is ln that I'm kind of hovering over with my cursor over here. ln 100, and then divided by ln of 2. ln of 2. And so press enter. There you have it. This is the answer. This is the approximate value. So x is approximately equal to 6.6439 if you run to the nearest 4 decimal places. Okay, sorry, I couldn't make this calculator to go bigger on the screen, but basically you have the idea. That's what you do with using the ln feature of your calculator to round it. All right, that's a very easy, very easy example that's very easy to grasp. Okay, here is another one that is not that easy to grasp. Not easy to work directly like that. Let me show you down here. So let's say I have one like this. Like 15 to the power of r plus 1 is 66. This has an extra step to it. So we need to make sure that this expression is by itself before we even start to do anything. Okay, so let's try to get that expression by itself. So what we'll do is to subtract 1 from both sides, and then we're going to be left with 65 over here, and then the left side will just be 15 to the power of r. Now we're back to the easy one that we just did. So what we need to do is to do ln of both sides. ln of 15 to the power of r is the ln of 65. And then we can divide, we can put the r in the front again. R times ln of 15 is the ln of 65. And then now you can divide both sides by ln of 15. ln of 15. So you're going to have r equals ln 65 divided by ln 15. Okay, that's the exact value. If I want an approximate value, then I need to go ahead and do my calculator one more time. So I have my calculator over here. I just do ln of 65. Yep. Let's see if the light can come on a little bit some more with the calculator. Oh, more so like that. Okay, maybe you can see more. And then divided by ln 15. ln 15. And then press enter. That's all there is to it. Just, isolating the variable and then isolating the exponent expression and then, taking ln from both sides and then simplifying it. And now we can write this as 1 point approximately. Don't forget to use approximately equal to 1.5415. 415. That is, I'm approximating what's on the screen right there on the calculator screen. Okay, so now as you can guess or imagine in math, you get difficulty is going to increase little by little. Okay, so here is another one that has like a fraction, like a number multiplying the exponent. This number here is a multiplication of the exponent expression, but we never, ever multiply these two things. Never, because that does not follow the order of operations. So what we will do first is to get rid of this -3 over here. That's multiplying. We need to get rid of it by division. So do not multiply. You're going to divide it like that. Okay. So I know that the right side is going to give me some number that is going to be totally, decimal that does not end. So I am going to leave it to the very end to evaluate that. So I'm going to just write like 44 divided by 3. Okay, that's the right side. And the left side will be 4 to the power of a. And now I can actually take ln from here, the natural logarithm of both sides. This is a. So I do ln of 4a equals ln of 44 over 3. And now I can move this is 4 to the power of a, just to be careful with the exponent there. And then I can move the a to the front as a times ln of 4, and then equals ln of 44 over 3. And now I can divide both sides to get a equals ln of 44 divided by 3 over ln of 4. Okay, so let me show you. Whenever you have a fraction like this, there's a fraction there, you can just type it in straight as input of your ln. So like so, ln of 44 divided by 3, see, and then divided by ln of 4, like so. That's it. And then that's the approximate value is approximately 1.9372. A is approximately equal to 1.9372. All right, now you can imagine a more complicated one is coming. So I have something like this, like number 14. All right, look over here. So our goal is to get this expression by itself, the one I highlighted in yellow. So we need to get rid of this 6 plus 6. We need to get rid of that 10 over there. All right, so we do the opposite to get rid of those. So we start with the -6 on both sides. And that will give me, this is -6, okay? That will give me, this is going to cancel out, and I'm going to have 49, I'm sorry. This is 49, 15, yeah, that's 49 on the right side. And then here will be 10 times e to the power of 5x plus 2. Okay, so what we're going to do is this. We are going to divide both sides by 10. And then we can have e to the power of 5x plus 2 equals 4.9. I can keep this one because the decimal terminates. It's not like the previous one that goes on and on and on. So I can just keep it at 4.9, okay? So now I'm ready to take natural logarithm of both sides. You are not ready until it is like totally cleaned up like this. So I do ln e to the power of 5x plus 2 equals ln 4.9. So now what we're going to do is we are going to move this whole exponent. This exponent over here is going to come to the front. All of it. So it will be 5x plus 2 and then ln e equals ln 4.9. Okay, so in one of our classes, we talk about ln e, just like you would do if you do log base 2 of 2. The answer was 1 because 2 to the power of 1 is 2, okay? The same thing we did log base 10 of 10 is 1 because 10 to the power of 1 is 10. Okay, now we have log base e of e. This is ln. This guy right here is ln. So log base e of e is also 1 because e to the power of 1 is e. So every time you see ln and e, you're taking logarithm of e, the answer will always be 1. All right, that's just a review of something we did in class before. So now this expression on the left side, this guy over here, I'm going to highlight in yellow, is really 1. It's 1. ln of e is 1. You need to get a note if you were absent. So that's 1 times 5x plus 2 equals ln of 4.9. So the next step now is to actually, we don't have anything to divide by. We're just going to write it like that. 5x plus 2 equals ln 4.9. You see, there's nothing to divide by. So whenever the base is e, like in this case, the base is e over here, then it's really straightforward, more straightforward. We don't need to divide by anything. So the only thing left now is we can't take the ln 4.9 yet. We have to wait. We have to do all this. We have to get rid of this 2, get rid of this 5, one at a time. So we're going to do minus 2 on both sides. So 5x equals ln 4.9 minus 2. All right. So we just got rid of that 2. Now we're going to divide by 5. Divide by 5. Divide by 5. So x equals ln 4.9 minus 2 all divided by 5. So now we're going to turn on our calculator one more time and then we're going to do ln of 49. Watch how I'm going to do it. There are several ways to do this, but the safe way in which I'm going to do something contrary to the order of operation is to do one at a time, like I'm going to do ln of 4.9, and then it's the minus 2. That's okay. It's going to do the ln first before taking 2 from it. Okay, I don't want to do divide by 5 right now because it's going to divide 2 by 5. So I better just press enter to give me what's the answer to that. That is the answer to the ln 4.9 minus 2. Now I can divide by 5. Divided by 5, the answer divided by 5 will give me negative 0.821. So x is approximately equal to negative 0.821. 0.821. Okay, so basically that's how you deal with whenever you have a lot of multiple operation that's attached to the natural logarithm on the right side. Okay, this might be another one that might be interesting for you to tackle. Look at it over here. We have the same process. So we subtract 3 from both sides. All right, and then you get 9 ex to the power of x over 3 equals 12. And now we divide by 9, and then you have ex to the power of 3 equals, I can simplify this to be 4 over 3. I'll keep it that way because if I try to divide 4 over 3 like I do like this, it's going to give me some repeating decimal. I can't use all of them, so I better keep it as fraction until the very, very end. Now I'm ready to do the ln. I'll do ln of x to the power of 3, ln of 4 divided by 3. And now I can take the x divided by 3 to the outside and then do ln of ln 4 divided by 3. Now I am going to ln of is 1, so x, the left side is just x over 3, and now 4 divided by 3. So I want to get rid of these 3, so I multiply both sides by 3. So then the left side is going to be gone, x is left. I can write this 3 in the front like this, 3 ln 4 divided by 3. This is what I'm going to type on my calculator to get an approximate value. So x is approximately equal to, so I can just type it the way it is, like 3 times ln of 4 divided by 3. And then I will get 0.8630. So basically that's what you do. Now I'll do 2 more examples and then we'll be done. Let's go to the one that has something on the right side, like number 19 over here. So as you see, the e is not on the left side, it's on the right side. That's okay. So what we need to do is to divide both sides. We want to get this e, we want to get this expression by itself. So we get it by itself. We get rid of the 60, we get rid of this 60, we get it, and I think that's all we need to get rid of right now. So we're going to divide both sides by 60. Let's divide both sides by 60. So like so, divided by 60, divided by 60, and this is gone. And then we have 80 divided by 60 is going to be some repeating decimal. 80 divided by 60 it's going to be some repeating decimal. So I don't want to keep it that way. I want to keep it as fraction. So it's basically 80 divided by 6, which you can change to a fraction as 4 over 3. Okay, this is 4 over 3 equals e to the power of 0.5x. And now you can actually take ln of both sides right now. Okay, so ln of 4 over 3 equals ln of e to the power of 0.5x. As usual, this 0.5x is going to come to the front over here. So ln of 4 over 3 equals 0.5x, and then ln of e, and then times ln of e. Ln of e is just 1, so that is gone. That's 1. So you have only this left. Now, to get x by itself, we need to divide both sides by 0.5. So divided by 0.5, divided by 0.5. Okay, so now this is the exact solution. If you want approximately, we're just going to do x is approximately equal to, and then we can type this guy over there that I highlighted. We can type it to our calculator one time like that. Let's try to type it. So it will be ln 4 divided by 3, and then all divided by 0.5, and then enter. So we'll get 0.575354, 0.5754. Okay, so I'll do one more that's a little bit that looks complicated, but it's not. They're all basically the same kind of idea. I'm looking for one that might look a little bit complicated, which really is not. All right. Here is one over here that, might look intimidating, but it's not really. So we need to get rid of this 20. That's the first thing we need to do. Divide by 20, divide by 20. And then, when you divide 350 by 20, you will get 350 divided by 20, because I already, by 2 rather, I already cancel one of the zeros. So 350 divided by 2 will give you 175. So this is 175 equals 1/2 and 3 to the power of x. Okay, so now we're ready to take ln on both sides. Ln, well, let's do it on a separate line. Ln 175 equals ln 1/2 to the power of 3x. This 3x is going to come to the front. Just the same process. So with 3x ln 1/2. 3x times ln 1/2, and this is ln 175. Now we can divide both sides now because we don't ln 1/2, we don't know it. So we divide by ln 1/2. Ln 1/2. Okay, now we're ready to write that as 3x equals ln 175 divided by ln 1/2. So we can actually find x by dividing by 3 like this. By 3. So we're going to divide by 3. Divide both sides by 3. So we on this side we divide by 3 is 1/3 on this side times 1/3. Okay, so this 3 we can actually move it to the front like this. This is something that you get from practice. 3 times ln 1/2. Okay, looks a little big, but it's basically this 3 can go by commutative property over there. Okay. All right, now we're ready to do the approximate value. This is x. So x is approximately equal to. So the calculator will do the rest of the work. So it will be ln 175. See, what I'm going to do is I'm going to divide twice. I'll divide it first by 3, or divided by ln 1/2. So divided by ln 1/2. It doesn't matter the order. 1 divided by 2. Okay, it's important you do it one step at a time like this. And now we can divide the answer by 3. Divided by 3. That's how you do it. And then you're going to get negative 2.4837. See, you have to do this by whenever you divide them by more than one quantity, you have to do it in steps, like I just showed you. Well, I hope this helps. It's a long video, but just look at the portion that pertains to you to get the idea. Basically, I hope it helps.